Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll cover this year 9 combined science 5129. It's a combined science curriculum, so actually it consists of physics, chemistry as well as biology. But I'll just be doing the chemistry aspect of it, which is on the atomic structure and chemical bonding stuff for this particular topical test. So this is suitable for any year 9 students or year 10 and year 11s who are revising for these particular topics, as these are a bunch of related concepts that will be useful if you're preparing for an exam or a test or whatnot. Yeah. So in this first question, this is what I usually term as the international standard because of the international format. This is the way the notation always appear in the exam or in a test format. In a formal setting is different from your periodic table format. In a periodic table setting, you will have things like nitrogen and 7 and 14, where they tell you that this is atomic number, and then they say that this is relative atomic mass. However, when you are given the international standard, they will be looking like this on the far left hand side instead of in the center. On the far left hand side, the number at the bottom, this is what you call atomic number. So it's still the same thing, but it has another name called proton number. So I should really call the other one from the periodic table proton atomic number. However, this number on top is no longer what you call relative atomic mass. It's what you call a mass number, or you call it nucleon number. So very specific now. It's supposed to be a whole number instead of something with decimal place. This can be something with decimal place because these are average mass, by the way. So use words from the list. In this type of question, we are using words from the list, so we do not try to come up with things that are new, like otherwise you will be breaking the rules, which are not reading the question. So we can start to fill it in after we realize that we can use one term once, more than once, or not at all. So X is the symbol for the atom. If you want, you can put down element as well. So you also score the mark, but it's not my favorite term because there are some elements such as H2, Cl2, Br2, I2, F2, O2, N2. All these are from the syllabus and they are all elements and they don't really exist as single atoms. They exist as molecules, but the marking scheme does say accept element as well instead of just writing atom. Alright, so A, which is the number on top there, actually represent mass number or nucleon number. There's no mass given in the list here, but there is nucleons. The most common mistake the student put in is they just put down neutron number, but nucleon number is the correct answer because it's the total number of particles that are in the nucleus, which includes this thing is equal to number of protons plus the number of neutrons. So some students know what it means, but when they write it down, somehow their brain is telling them it's neutron instead of nucleon. Nucleon refer to both the protons and the neutrons is the total number of particles in the nucleus of an atom. So A is the nucleon number, Z is the proton number or the atomic number, but there is no option for atomic number given there. There's just proton number. Question 2 is about completing the sentences. This is about isotope of silicon. This is the international format we were just talking about, 30, 14, and then silicon. This number at the bottom is the proton or the atomic number. It basically means there are 14 protons. And what we have on top there, this is mass or nucleon number. And this basically tells us that there are 14 protons, but we don't know how many neutrons. Alright, so it's the number of protons plus the number of neutrons. I know about the number of protons because the proton number there is 14. Anyway, so they say something of an element in doing this kind of question, filling in the blank, you do not just fill in randomly. You really need to actually read the sentence and make sure that whatever you put in does actually make sense in the context of English language, as well as the sentences itself, because reading is a skill from primary school and you build up in secondary, lower secondary, and now in upper secondary. So this is about position of the element. So each element in the periodic table is arranged in terms of their atomic number. So that is their proton number. So each element has a different proton number, has a different atomic number. It is this number as shown in the periodic table. This is the number that's increasing from 1 to 2 to 3 to 4 to 5, etc., etc., given in the periodic table for free in your exam in front of you. All right. So this isotope of silicon. So if you read this question, you can't use periodic table. You gotta use this isotope. It contains how many protons and how many neutrons. So there's 14 protons, and there is 30 minus 14 because I want this to be the subject. So 30 will be here, 30 minus 14, and I'll get 16 neutrons, because 30 minus 14. Do this on your calculator, you get 16 neutrons. Isotopes of the same element, because they are the same element, they have the same identity, so it's the same number of protons and electrons, because they are atoms of the same element. So number of protons equal to number of electrons. Since they are the same element, they have same number of protons, and therefore same number of electrons. But what is different will be the number of neutrons. Now they say atom. Okay, so number of protons equal to number of electrons, or the number of electrons equal to number of protons. So we're looking at period 3 and group 4. So 2 in the first shell, 8 in the second shell, and 4 in the third shell. First shell, second shell, third shell, period 3. And then group 4, because 4 valence electrons, group number is given to you in the periodic table for free, all that for 4 marks. The next question is basically very similar to what we had talked about earlier. In this international format, you have 15 nucleons, and this is equal to 7 protons plus how many neutrons? That's the question. All right, and then 7 there refer to 7 protons. Okay, because you have 7 protons, if you count the particle in the nucleus of an atom, because they said this is atomic structure of an atom, we have seen some random answers here, but you really must think about what are the particles in the nucleus of an atom. These are straight from the syllabus as part of the learning objective. That is your checklist when you revise. You do not just revise by reading, you revise by going through the checklist, because that's what a smart student would do. So make sure that you don't miss anything, as well as in your notes, as well as in your exercise, as well as in your corrections. So all these are done so that you know exactly what you have missed out, and it's something that you need to address if it is something that you have struggled on. Looking at the non-bolded stuff and the bolded stuff, if you count, you have 1, 2, 3, 4, 5, 6, 7. You have 7 of these. And then the bolded stuff, you have 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 of that. I have 15 nucleons according to the information given in this international format. I have 7 protons. So the white stuff, when they say name the particle, name the particles. They are not looking for metal or non-metal. They are looking for the particles in the nucleus of an atom. Consists of nucleons. Nucleons are protons and neutrons. So the white color one is going to be your proton, and your dark color one, the bolded one, is going to be your neutron, because you have 8 of them, and 7 protons and 8 neutrons. Now the atom forms an ion. So the atom forms an ion. It has got a formula 3 minus. So this is called anion. Anion is because the non-metals gain electrons. So straight to the point, we gotta think about, describe how this ion is formed. Because you know how to read the question, you don't just read the last part. You don't just get 3 lines for just answering this thing, because each and every part of the question is something you have to address. And that's why I like to put numbers, because I get confused easily, because I lost track of what the question wants me to do, and because I want to do well in exam. So how this ion is formed is the atom the atom gain 3 electrons. Got to be very specific. If you say gain electrons, you don't get the mark because it's a 3 minus ion. They say this ion. This ion refer to, this ion refer to this thing with 3 minus. So it gain 3 electrons to form N3 minus ion. Straight to the point. Why this ion is stable? This is a very, very popular question. If you think about the nitrogen atom, it has got 2 and 5 because 2 electrons in the first shell, and then it's got 1, 2, 3, 4, 5. As you know, it's in period 2, so 2 shells, and it's in group 5 nitrogen, so 5 outer shell electrons. 5 outer shell electrons, and you want to go to a fully filled outer shell. Now becomes N3 minus. After you gain 3 electrons, N3 minus has a fully filled outer shell. That's the most important thing. N3 minus, not N atom, has a fully filled outermost, or you can use the word valence. Just choose whichever one you like. You don't need to write both, but the idea really is fully filled valence shell. That is the most important bit for why the ion is stable, and you get 2 marks because 2 points to be made there. Alright, question 4. This is carbon dioxide. So the structure of a molecule of carbon dioxide, CO2. As you know, carbon and oxygen, 2, 4, and 2, 6. You need to share how many? We're talking about sharing electrons because we have non-metal and non-metal, group 4 and group 6, non-metal and non-metal. You need 4 electrons. You need not 6 electrons. You need 2 more electrons in order to complete the outer shell. Complete the outer or the valence shell. That is the objective when you form covalent bond. And then we do the cross multiply where the number 2 goes to the other side, and then the number 4 goes to the other side. This is number of electrons, this is number, and you need to simplify into the simplest ratio. And all this was done as part of your lesson notes. They're in your textbooks. They're also in the corrections that we did as a class, where everyone had the chance to ask questions if they were unclear on what is going on. So this 1 time carbon and this 2 time oxygen, so CO2 is going to be the formula of carbon dioxide when carbon combined with oxygen to get to a fully filled outer shell. This is 1 covalent bond. The bottom one is another covalent bond. So 1 covalent bond is 2 electrons because 2 electrons are being shared. So altogether, if you have 2 covalent bond, you call it double covalent bond. You have 4 electrons being shared. If I say the carbon is cross, the oxygen is dot, then it looks like this. This is 1 covalent bond, 2 electrons. This is another covalent bond, 2 electrons. Being able to translate from these to these is very important. And of course, oxygen started from 6 valence electrons, being in group 6. These are outer shell, meaning to say these are valence. We don't care about the inner shell anymore. We care about you started with 6, you only use 2, so you still have 4 more. If you forget that you have 4 more, then you don't get the full mark. On the other side, you have the same double covalent bond. So what I have is I have the 2 crosses from carbon sharing the 2 electrons, and the oxygen will share 2 electrons, and now the oxygen also has 4 more electrons which are not used for bonding. So if you count now, the oxygen started with 6 dots because 6 valence electrons. It now share with 2 from carbon. Now this oxygen has 8 electrons in the outer shell. This oxygen started with 6 dots and it shared 2 crosses from the carbon. So now it has 8 electrons in the outer shell. This carbon started with 4 crosses and now it shares 4 of the outer shell electrons with 4 more, 2 from each oxygen. So now 1, 2, 3, 4, 5, 6, 7, 8. This carbon has fully filled outer shell. You got to check in order to get your full marks just like that. The next bit of the question was very, very badly done by a lot of students because you did not focus on properties. Properties is not the process. Not like between metal and non-metal, blah blah blah, not like sharing or transfer of electrons. but rather properties are stated in the syllabus in your notes as part of electrical conductivity as well as melting and boiling point. So covalent versus ionic. Covalent compound has low melting and boiling point. Covalent compound has low melting and boiling points. These are stated very clearly. They are not asking you to explain, they're asking you to state, but they say differ. So you gotta talk about ionic compound as well. Ionic compound is in contrast, so it has high melting and boiling point. You gotta know how to explain it as well, because they stated in the syllabus. Candidates should be able to state and explain, describe and explain. All right, so that is to do with melting point and boiling point. The next thing is to do with electrical conductivity. This is also stated in the syllabus as well as the notes. Those who didn't do the complete checklist, that means you did not completely revise no matter how long you spent on revision. If you do not complete the checklist from the syllabus, you are not doing an effective revision at all. So covalent compound does not conduct electricity at all. Does not conduct electricity at all, whether you are solid, liquid, or gas, or aqueous. But ionic compound, so we know ionic compound can conduct electricity when aqueous conducts electricity only when liquid or aqueous. Aqueous mean dissolve in water. Liquid mean when you melt it to become liquid. All right, so you got to talk about the two different properties. These are properties and these are not the process itself. When you start talking about the process, straight away you get marked down to 0. So in this next question, so we have this table which shows the arrangement of electrons, and these are in atoms. So we know that in atoms, number of protons equal to number of electrons, and these letters are not the chemical symbol of the elements, and they say use the letters. So we do not have to work out the element, we need to use the letters and to think about the information given. This is saying that there is first shell, and this second shell, and there's no third shell because it only fill up to second shell. So the first shell is completely filled with 2 electrons. The second shell, which is the outermost shell in this case, it's got 1 electron. So that means it's group 1, and group 1 is a metal, group 1 metal. And this one is period 3 because it's got first shell, second shell, and third shell. And in the third shell, in the outermost shell, there's 5 valence electrons, so it's group 5. And this one is a non-metal. So moving on, what do we have? We have period 2, because there are 2 shells that are being filled, and this is group 6, and this is non-metal. And so on and so forth. This one is period 3 and group 7, and this is also a non-metal. Last but not least, this is period 3 and group 2, which is also a metal. So the group number basically tells you the number of valence electron or the number of outermost shell electrons. The period number, you can get the information by looking at how many shells are being filled. So here 2 shells are being filled, first and second. Here there's first, second, and third. So this is in period 3, and so on and so forth. So out of these, you can use the letter once, more than once, or not at all. So the element with the proton number 15, so we are looking at 15 electron also because of what we have read earlier in the question. Of course, we read the question because that's the first thing that any sensible people would do. They read the question before they jump into the question. All right. So the element with the proton number 15 is going to be where the number of electrons add up to 15. So there are a total of 3 electrons here, 2 plus 1. So there's a total of 2 plus 8, which is 10, plus 5, which is 15. So we're looking at B as the only element with the proton number 15. That's the identity. The element with the nucleon number 35 and 18 neutrons. So if you think about this is like X, and then it's got 35 and we don't know the number at the bottom. That's what we don't know. We don't know the number at the bottom. So we know 35 minus whatever we don't know give us 18, because this is nucleon number and this is the proton number. Nucleon number minus the proton number, nucleon or the mass number minus the proton or atomic number, and that will give you the number of neutrons. They will give you the number of neutrons, and since we know that, then we got to work out what is our missing piece, and moving the minus missing piece to the other side, you get the unknown, and you get 35 minus 18, so unknown equal to 17. You work this out on your calculator. 17 protons. 17 protons would mean 17 electrons, because we are talking about atoms. So 2 plus 8 is 10, plus 7 is 17. So we're looking at D as our only possible answer. The next one is asking us on non-metallic elements. They're also asking us on the same period. So same period means same number of shells being filled in. We're looking at non-metal and non-metal because they say non-metallic, which are found on the right side of the periodic table from group 4, 5, 6, 7, and 8. This is group 4 non-metal. This is group 7 non-metals. They are in the same period because period 3 and period 3, first, second, and third, first, second, and third shell. So we're looking at B and D. All right, this is a metal. This is a metal. This is a non-metal, but this is in period 2 because they only fill 2 shells, so C cannot be the answer compared to these two which are in the same period. The next one, an element that form an ionic compound with fluorine. Fluorine is a group 7 non-metal. So you're looking for a partner. Ionic, your partner will be metal and non-metal. So since we have non-metal, we're looking for metal. Could be this group 1 metal. It could also be this group 2 metal. So A or E could be the answer here. They don't say the element. Here they say the. Here they say N, because there's more than one answer that's possible. So it could be the group 1 metal, which is A, or the group 2 metal, which is E. So either you put down A or you put down E, that will be correct as well. The element, meaning there's only one answer, gains 2 electrons. The fact that you gain 2 electrons means you're a non-metal. And specifically, why do you gain 2 electrons? Because you are stable and you want your ion to be stable because it will have a fully filled outer shell, and therefore we're looking at group 6 because 6 plus 2 will give you 8 electrons, fully filled outer shell. Fully filled valence shell will be nice and happy. So we're looking at group 6, and the only group 6 element in this case would be element C. Okay, so on to the next part of the question. We got to complete the sentences about nonmetals. So nonmetals are found on the right hand side. So a lot of students have actually filled this in incorrectly, partly because 1, they just fill in the blank randomly, and 2, they don't know anything about a generalization of metals and nonmetals. These questions are meant to guide the students by giving information on the left as well as on the right. You got to think about properties. So these are properties as stated in syllabus as well as the notes. If we think about the nonmetals, we can think about nonmetals are mostly gases, i.e. we can think about H2 hydrogen gas, O2, N2, Cl2, etc., etc. These are part of the bonding topic. As you know, these are single covalent bond, double covalent bond, triple covalent bond, because you only want to share 1 electrons to complete the outer shell. Group 6, it wants to share 2 electrons to complete the outer shell. Group 5, it wants to share 3 electrons to complete the outer shell. Group 7, it wants to share 1 electrons to go to 8 electrons in the outer shell. Sharing of electrons, covalent bond, therefore, the properties will be low melting point. They also have a low density. They are mostly gases. They are not found on the ground level. And the other thing is they form negative ions. The other name of negative ion is called anions. So what happened to electrons? The nonmetals, the atoms will gain electrons or accept or receive electrons. And then the electronic structure of the negative ion, the anion, is stable, such as what we said just now. You want to form a stable ion because you want to get to a fully filled valence shell. Valence is the other word equivalent to outermost electron shell. So valence electron shell will be completely filled. Or you can say full, or you can say fully filled. They all mean the same thing. If your valence electron shell is fully filled, that means you are forming a stable ion. In this case, the negative ion, because you gain however many electrons in order to form a stable ion. On to the last part, nonmetals combined with metals, and this will give you ionic compound. If you want to get covalent, you want nonmetals with nonmetals, they will give you covalent compound. Alright, so moving on to the next part of the questions, we have electronic structure of an atom. This is atom, and the other one is atom. This is group 7, and it's in period 3. So as we mentioned just now, this is first shell, second shell, and third shell. So we're talking about period 3, and we're talking about group 7 because the outermost shell has 7 valence electrons. Speaking of which, this is the very answer to this part of the question. A lot of students, they put down because chlorine is a non-metal, and that's actually wrong, because they specifically ask you group number. In the syllabus, in the notes, they say students should be able to state group number tells you the number of valence electron. Group number tells you the number of valence electron. If you are group 7, that is because all the elements in group 7 has 7 outer shell electrons. So chlorine has 7 outermost shell electrons. Or we said chlorine has 7 valence or outermost shell electrons. Just choose either one and you'll be okay with whichever word you decide to use. However, you cannot put down just because it's non-metal. Not chlorine is a non-metal. Because if you say that is true, then every single non-metal I can also put in group 7 and that will be true. But that is not true for every single non-metal. There are some other non-metals that are put in group 6. There are some other non-metals that are put in group 5 because it depends on the number of outermost or valence shell electrons. So group 7 because there's 7 valence electrons. End of the story. Alright, so moving back to part A, they want formula. So I don't know why a lot of students, they put down configuration when they should be reading the question. Formula is not electronic structure, it's not electronic arrangement. Now they want ion and they want ion. So we know what happened with this sodium 2 at 1 and this chlorine and 2 at 7 is that the chlorine will receive the electrons from the sodium. So this one loses electrons. This one will gain the electrons and you get Cl minus 1 and then you get Na plus 1. The whole idea of this losing 1 valence electrons and this coincidentally gaining 1 electron is because when this lose the outer shell electrons, the Na plus and the resulting Cl minus will become 288. Now they would have fully filled valence shell. Valence or outermost, you can choose either one, but should stick with just one that you are happy with. So now they have, not electrons, but shell. We are talking about fully filled outer shell. That's the objective of forming the particular ion with a particular charge. Is because you want to form ions that are stable because they have fully filled valence or outermost shell. So the formula of the resulting sodium ion is just Na plus and the chloride ion is just Cl minus. Based on what you know about the very, very basic fundamental concept of electronic structure, they are given for free in the periodic table. You gotta know about what happened. You gotta know the resulting charges that this loses electrons to give you cation. Non-metals gain electrons to give you anions. On to the next part of the question. So they told you that it's ionic compound because you have a metal and a non-metal combined together. Now you got to give properties to show that it's ionic compound. A lot of students, they get confused between this word properties and the process. The process involving metal and non-metal. So there's the process involving the transfer of electrons from the metal to the non-metal. That is the process. You want properties as stated very, very clearly in the syllabus, and also I mentioned very, very clearly in the classes as well as lecture tutorials that you shouldn't revise without going through the syllabus and making sure that you understand and can master each and everything stated in the syllabus. The properties does not mention the process. There are two properties. The first one is to do with high melting and boiling point. The second one is to do with electrical conductivity. So ionic compound, or in this case sodium chloride, NaCl, the formula of which is stated in the syllabus as something you've got to know, because you have one Na plus as a result of one Cl minus. So ionic compound NaCl does not conduct in the solid state. So solid ionic compounds do not conduct, but it can conduct electricity. We are talking about electricity in the liquid, meaning molten, or aqueous, meaning dissolved in water. So all of these was already covered in the notes. You're not asked for the reason here, but the reason is because you do not have free ions in a solid state. The ions are in a fixed position, and the ions are free to move once they become liquid or dissolve in water. And the reason for the high melting and boiling point is because you have strong ionic bond. You need a lot of energy to break strong ionic bond, and these are all part of your summary notes, which you should have done yourself. We already gone through this in the class as well. They're also present in your lecture notes as well. So the next part of the question, so we have an atom of hydrogen, and we have this international standard again and again. So there's our proton or atomic number, and the number on top is our nucleon or the mass number. State how this atom of hydrogen differs from all the other elements. All other elements would definitely have different identity, therefore different proton number. So they all other elements have different proton number or atomic number, proton or atomic number, whichever one you like to do or use, than this atom. Of course, you can have other isotopes of hydrogen, such as 1,1 hydrogen, 2,1, and 3,1 hydrogen, but they will be atoms of the same element, and they are called isotope because they have same number of protons but different number of neutrons, where this one has 0 neutrons because 1 minus 1 is 0, 2 minus 1 give you 1 neutron, 3 minus 1 give you 2 neutron. The next part is basically about the molecule of water. So we know H2O, hydrogen has got 1 electron only, oxygen has got 2 6 electronic configuration, period 2, second row of periodic table, group 6 with 6 valence electrons. You need how many electrons? You need to share 1 electrons for the hydrogen and 2 electrons for the oxygen. And then you can think about cross multiplying, where we bring down the number 2 there to the other side and 1 there. This means hydrogen and oxygen, and therefore the formula how you combine them is H2O. The hydrogen only needs 1 electron to share, so the hydrogen will only give you 1 electrons per hydrogen. But if the hydrogen give 1 electron only, the oxygen must give 1 electron only. If this hydrogen give only 1 electron for sharing, this oxygen must only give 1 electron for sharing. My oxygen, this question says outer shell electrons, so I'm just looking at 6 valence electrons, 6 outer shell electrons. So I already used 2 for bonding. Now I'm left with 4 more. Do not ever forget these, and do not ever forget to count and read. They only say valence, so you do not need to draw the inner shell. And hydrogen obviously only has 1 electrons, which is just 1 cross there. Altogether you got 6 dots, and then you share with 2 more from the 2 hydrogen. You got 8 electrons in the outer shell. Hydrogen started with one cross and now it share one from oxygen. Now this hydrogen has got fully filled first electron shell, same for these, and therefore all the atoms have got fully filled outer shell, and therefore it's a stable compound. This is H2O, the formula of which represent water. It's one of the things stated in the notes, stated in the syllabus, and this is your exercise from one of the work which you had done and which we had done corrections on, and which I told you are very, very important. C part 1 basically come from that earlier topic earlier in the year. We call it separation techniques, where we have learned about solute, solvent, as well as solution. If it is something that you have forgotten, then you got to work back and try and recall these things from earlier on, because you never know when it's going to come out, such as a case like this. This thing is the solute because it's the solid that dissolve in the solvent to give you the solution. So the water is acting as the solvent, the substance you use to dissolve the solute to give you the solution. Part 2 is basically talking about the boiling point of pure water. So liquid water going to steam is 100 degrees Celsius, something you know from lower secondary, I hope. What is the effect of adding sodium chloride? Sodium chloride is your table salt. So when you're cooking spaghetti, when you boil water, before you put the spaghetti in, you add in some salt because you want to increase, it will increase the boiling point of water. So table salt will increase the boiling point of water, and it will make the boiling point of water a bit higher than 100 degrees Celsius. If it is higher than 100 degrees Celsius, your water is a lot hotter and it will boil the spaghetti a lot faster. That's all for that 5-mark question. Moving on to this next question. So W, X, Y, Z are elements in the periodic table. These are isotope of each of these elements. They are not the chemical symbol of the elements. We're going to complete this table. So first of all, we have number of protons. The number of protons will be equal to number of electrons, because these are atoms, as we have been told earlier in the question, because they are elements, and elements contain or consist only one type of atoms, and these are definition from lower secondary, as well as from the topic on separation techniques, as well as on atomic structure under elements, compounds, and mixtures. This number on top is the nucleon number, and the number at the bottom, which you don't show here, but is proton or atomic number. So the proton atomic number is 12. So nucleon number minus proton number will give you the number of neutrons. So 24 minus 12. Put that into your calculator, because you're allowed calculator in the exam, so don't waste time and think about it. There are 12 protons, so 2 plus 8 plus 2 give you 12 electrons. Because you have an atom, number of protons equal to number of electrons. 14 protons, 14 neutrons. Together, protons and neutrons make up the nucleons, the particles in the nucleus of an atom. 14 plus 14 give you 28. Since you have 14 protons, you also have 14 electrons. So 2 in the first shell, 8 in the second shell. 2 plus 8 is 10. You need 4 more in the third shell. This is a group 4 element in the third period. Next one, you have 34 up there. So 34, you want to know 34 minus this will give you 18. So 34 minus 18 will give you the proton number, which is 16 proton, because 16 proton plus 18 neutron give me 34 nucleon. And I can also do that from 2 plus 8 plus 6, which is 16 electrons. Number of protons equal to number of electrons for atoms. Last but not least, 17 plus 20, that will give you my nucleon number, 37. My electronic structure will be 17 electrons, so it's 2, 8, and 7. Because 2 in the first shell, 8 is full in the second shell. Go to the third shell, 2 plus 8 is 10. I need 7 more to reach up to 17 electrons. Part B, this is choosing letters. If you read the question, then you got to try and circle and underline stuff, because we are very forgetful. We do not want to be, doing the wrong stuff by not circling or underlining important information. So each letter may be used once, more than once, or not at all. We are looking at the element that is a metal. The, and the. So that means only one answer. There is no option at all. because it's the. Alright, it's not a or an, it's the, meaning there's only one answer. Metal, so we're looking at the valence electrons. So this is group 2, this is group 4, group 6 and group 7. Group 2 is metal, 4, 6 and 7 are non-metal, so we're looking at W. They want the letters. The element that form an ion with a -1 charge. -1 charge is an anion. You gain 1 electrons because it's a -1 charge. You want to gain 1 electrons to complete your outer shell. We are looking at group 7 because 7 plus 1 will give me 8 electrons in the outer shell. So -1 charge will come from Z. Last part of this question, the elements that form a covalent bond. So we're looking at non-metal and non-metal. So non-metal and non-metal. So straight away you can cross out the metal option, which was W there. So cannot be W. So you're left with X, Y, or Z. Now your next hint come in. 1 atom of the element combines with 2 atoms of fluorine. So you gotta have 2 atoms of fluorine. Fluorine is 2,7 because it's period 2 and group 7. So it's got 7 outer shell electrons. And we're gonna have 2 of them. So this one will share 1 electrons. Another fluorine atoms will share 1 electrons. So altogether you have 1 of something, and you share 1 electron, 1 electrons, but you only have 1 of these and 2 of these. So this one share 1 electron, 1 electron. So this one needs to share 2 electrons. All right, 2 electrons, and therefore we're looking at group 6 because 6 plus 2 will give you 8, which is fully filled outer shell. You need to share 2 electrons for just 1 of these in order to fit in with 2 fluorine according to the question. So group 6, we're looking at 6 valence electrons, so there must be Y there. Moving on to the next part of the question, so we are told that we need to use the data in the table to show that these are isotopes. The data in the table, there are 3 pieces of data, number 1, number 2, and number 3. Okay, this is a very simple question. It's basically asking you what is isotope. This is a 2 marks thing. You really do not want to mess this up. There are same number of protons and same number of electrons because that's how the definition of isotopes are like. Atoms of the same element with the same number of protons but different number of neutrons. But here you're given the number of protons as well as number of electrons. So I've got to use the number of electrons as well because I am just reading the question. I'm just reading the data. So this tests your skills. Do you know how to read this data? Are they the same? Are they different? All right. But then X, Y, and Z have a different number of neutrons because as you could see, they are different there. 8, 9, and 10 neutrons. So different number of neutrons. Alright, so basically X will look like 8 protons, and 8 plus 8 is 16 because number of protons plus the number of neutrons will give you the nucleon number. It will give you the nucleon number, which we have talked about again and again and again, which is this number on top there. Versus Y, which is 17, 8, versus Z, which is 18 and 8. Anyway, so you want Y, and they say there's the nucleus. Nucleus contain nucleons. Nucleons contains protons and also neutrons. Is one of the earlier questions in this test paper. They only want the electronic structure. They don't care about what is in the nucleus. So we show the dot, the crosses for the electrons. Atom Y, so this is Y. We have 8 electrons. We have 8 electrons for Y. So 2 in the first shell, and then you gotta have 6 in the second shell, because 2 plus 6 will give me 8 electron total, but I can only fit 2 electrons in the first shell. This leaves me 6 electrons in the second shell. Next up, identify the element Y from the periodic table. Well, periodic table, you have proton or the atomic number. So have a look at the table above, for Y, you have 8 protons. What tells you the number of protons? The proton number or the atomic number tells you the number of protons. So since you have 8 protons, we are looking at element number 8 in the periodic table. So there's got to be oxygen. Identify, there's an English word that you got to learn what it means for that 1 mark. And the end is a total of 4 marks in that question. Alright, so that's the end. So that's the end of this tutorial. And yeah, I hope that has been useful. And do raise up any issues you have when you see me in school or in classes. And yeah, don't wait before it's too late if you wish to improve for the next exam or the next test. Alright, so thank you for watching, and click the button on the bottom right to subscribe to the channel. Follow me at ptet.chemistry on Facebook, Instagram, and Twitter to get connected.